Okay, so this is a video response to Michael Penn. I mean, you probably know him. He's like really good. But just in case you don't, this is, I'm pretty sure, the name of his channel. So yeah, yesterday I was watching one of his videos and I just thought, well, maybe I should do something regarding responding to this. So basically it ended up in this form, right? So this expression has interesting values, has an interesting evaluation at which values of n, right? So well, I thought of this, right? So I was like, okay, so let's expand this a little, right? So n squared plus n times phi n minus 11 upon 48. That's that's that, right? So okay, so just off the bat we can say that, well, any value of n that's less than 3, right, will imply that this expression, I'm just gonna name this 1 is less than 0, right? It's quite elementary to see that, but yeah. So like 5 times 3 is 15 and that minus 11 is positive, whereas 10 times no sorry 5 times 2 is 10, which minus 11 is minus 1, and that's a negative number, and those are strictly positive, right? Because you want positive values for n. So that's pretty clear to see. So if you want that next expression to be positive, right? Okay, so anyways, I was thinking, well, of course we want this to be an integer, and we know that this part is surely an integer because we know that n is an integer, yeah. But we don't know if this part is an integer and we want it to be an integer. So I was like, well, why not generalize this? So basically we want this phi n minus 11 upon 48 is some integer, say m. I'll just specify that m is an integer, right? Well, let's just, yeah, for the sake of it, let's just say it's a positive integer, right? Because you know that negative values, we just don't want negative values, we like positive things. Positivity is promoted. Anyways, phi n minus 11 is phi n minus 11 upon 48 is equal to m, right? So and m is just some arbitrary integer, we don't know what it is. This is basically like a Diophantine equation. So I'm just going to convert this into the following form. Phi n minus 11 is equal to 48 times m, right? Now of course we want like general solutions. I'm just going to put that in quotes, right, because I don't know what those solutions are. So anyways, we're going to take mod 48 on both sides, right? So phi n minus 11 is congruent to 0 mod 48, then phi n is congruent to 11 mod 48, and then right, let's think about this, right? So we want a number such that 5 times that number is 1 mod 48, or minus 1. Minus 1 would be just as nice, but well, we don't care. So let's think about this, right? 48 times 2, that's if I'm not wrong, that's 96. Yes, that's 96. And of course 5 times 19 is also it's 95, I should say, also. Yep. So well, let's just multiply both sides by 19. So what we get here is not minus yet, yeah, 95, n is congruent to 11 times 19 mod 48. Now 95 is congruent to minus 1 mod 48. I hope you know what like negative congruences mean in this stuff. Mod 48. Now let's think about this, right? What's 11 times 19? That's well, should we calculate it though? I guess we should. Why not? 11 times 19 is so let's do 11 times 20, right? So 20, 2 times 11, that's 220 minus 11, so that would be 209. Yes, 209, right? So n is congruent to minus 209. Now we're multiplying both sides by a negative 1 mod 48, right? Yeah, that's pretty cool. Anyways, 209 mod 48. So let's think about this. 209, well, 48, right? 480, then 240. So let's add 240 to both sides. Notice that that's just adding 0 in this ring of integers. I just learned that yesterday actually. But yeah, anyways, so we're adding 240 on both sides, which is 0 mod 48, just to make this positive, right? So that's going to be 31 mod 48. Yeah, that's pretty nice, and I hope that that's right? Yeah, I think that's right, but well, I guess we'll see. Anyways, so I don't have much time on my hands, but I guess we should evaluate like one expression. Let's like 31 mod 48, maybe like the smallest value. I don't know. Is this even right though? I don't know. It's weird. Well, I suppose it's right. Yeah. So the smallest like integer, the smallest natural value for n. So let's see, n is equal to 31, and let's plug that back into our equation into 1, right? So that's our equation. So we get the following. It's a 31 times 32, right? Times 5 times 31 minus 11. Okay. Well then, 5 times 31 minus 11 over 48. Yep, that's cool. So 5 times 31 would be, let's think about this. 5 times 31 would be, say, 150, 155, right? Yeah, 155. 31 times 32. So I'm just gonna calculate it. I don't even care. 5 and 15. Yeah, that's 155 minus 11 is 144 on 48. That's cool. 31 times 32, and then, well, of course, this is the smallest value, but this is like the one which we can get, like, obviously. Anyways, 31 times 32, and then 144 upon 48. Notice that, you can remove factors of 12 first, so that the 4 leaves a 4, that leaves 12. Then we can remove a factor of 4, that just leaves it with a 3. So yeah, 3 times 31 times 32. Let's calculate that. Yeah, maybe we should. I mean, 31 is like one of my favorite numbers, so yeah, that's pretty neat, by the way. 31, because it's like, cube root of 31 is a good approximation for pi, and then 31 is prime, then it's reversed or prime, and then, like, 31, the sum of its digits is like a perfect square, and it's really cool. It's a cool number. Okay, yeah, so 2 3s are 6, and 2 9s are 18. Okay, so 3 3s are 9, 3 9s are 27. Yeah, I can do math. Okay, 17 8 9 9, it's 2976. 2976 is what it evaluates to, which is, yeah, I'd say that's pretty neat. Okay.